So hey guys, it's me again. You see, I just figured out how to use the macro shot function of my camera in the video mode. So I wanted to tell you a little story about what happened to me today, and hopefully you could learn something from it, like I did. I've never done too much with inductors or transformers like this one. I salvaged this one from an old modem, and I just wanted to know how it behaved and what it did. So the first thing I did was measure the inductances with my LCR meter. So I just hooked the thing up to my LCR meter, switch it on, not capacitance, inductance. Okay, so the inductance of the input is about 11.2 henries actually. And I'm turning it around, measuring the output just in a moment. And the output is 14.8 henries. So I figured this wouldn't tell me much, and as you've seen in one of my previous videos, I use my function generator and my oscilloscope to automatically measure frequency response, so I tried that out. So that's the setup. My function generator hooked up to the input of the scope, where effectively only the peak-to-peak voltage is measured. So this is how I hooked it up. It's just my function generator output on one side and my oscilloscope probe on the other side. Notice it's in the times 10 position. And here you see the frequency sweep in action. And oh my god, there's a huge resonant spike. Where the hell does that come from? It's at about 100k. So this whole resonance seemed kind of fishy at first. So I started playing around with the circuit hooked up to the oscilloscope a little bit, and I noticed if I'm touching the point where the oscilloscope probe is attached, the resonance is damped down. I'm just touching it with my finger right now, so I figured there must be some capacitance in the picofarads range, just like the human body has, depending on moisture, etc. And then it dawned to me, is that a resonance coming from the oscilloscope probe itself? And I fired up my computer simulation program and found this. So this is what the schematics I used actually look like. This side is just generating the AC voltage. This is the output impedance of my function generator. Then the resistance of the primary winding, the resistance of the secondary winding, and here just the transformer using the same values as measured. And this over here is modeling my 10 times oscilloscope probe, and I duplicated this thing 3 times. This one is just using nothing on the output, and the one down here is with my oscilloscope on the ×1 magnification. So I simulated this, and let's look at the results. So this is the actual result of the simulation. We see it down here. The green line is with nothing connected to the output, this little red bump down here is with the ×1 oscilloscope probe, and this huge resonance spike is with the ×10 probe attached. And this magically resembles what we actually measured before. So I guess this concludes to we didn't actually measure the frequency response of our transformer, but we measured the resonance in between our transformer and the ×10 oscilloscope probe. So this is just something to think of if you try measuring something without knowing what it is, what it does, and you can get results that are just of no use if you don't think about them. So I hope you learned something from this, like I did, and thanks for watching. See you next time. Bye.